here let it be. So this is the x-axis. This will be y-axis. So this will become 30 degrees for us. Then the charged particle. I think this much of information is available with us. So it's asking now, velocity of particle when it comes out from the field, distance traveled by it in the field, what is the time spent by field. Are you able to understand? Yesterday we had a discussion where the charged particle was entering at an, we know whatever the shape of the field, what is the motion of charged particle, what will be the trajectory of charged particle in a magnetic field? Should be a part of a circle. Should be a part of circle. So I should bring now a circle here. First of all, so to predict that circle, so what has to be done? So the moment the charge particle enters here, there will calculate the magnetic force. So here it will be like a magnetic field, B bar. So then how the magnetic field is acting everywhere into the plane. Instead of showing many that into marks, okay, only one I'll show it. It should be understood. Okay, then B bar, Fleming's left-hand rule, B bar velocity. So how the magnetic force on the charge particle will act at this particular point, at entry point. Okay, this will take it A. Will act here. Then how the particle, it has to deviate. So it will deviate in this way. It should be part of circle. That's all, no doubt. You take it for granted. It should be part of circle. Then finally it will emerge. Then if you check it the way we have to, then you have to draw a circle and you have to show that the way the two forces are acting, there should be the center of curvature. I'll make arrow this little bit small, so drawing circle will become easier. Not correct. I'll bring circle directly. Center of circle. It is entering horizontal. Yeah. I'll make it small. Let this be. This arrow will make it small. I think it's really, you must have the geometrical skills, nothing to do here. So how the velocity vector at this point will be directed here. Then how the force, okay, we'll first get the force. So the force should act towards center of circle. And how the velocity vector, it should be directed perpendicular to that particular force. Similarly, the velocity vector here, it is in this direction. Okay, now we'll get into this one. So this should be the center of circle. A rough diagram, may not be exact. Rough diagram it is. Everywhere you should think about this one. This is the center of circle. Now let's get into the mathematics. There's a method of predicting. Now it will not move in circular path after leaving magnetic field. Hope everyone is able to understand. So here, what do we get? We get a condition like this. You see, no? Velocity of particle when it comes out. So can we go for the angles? What are all the various angles are there? This angle is 30 degrees, so this should be 60 degrees. Then let me drop a perpendicular. So this should be 30, 90. This will be 30. This will be 60. This total angle will be 90. Total angle, that should be the 90. Okay, this angle, because these two should be perpendicular. This angle is 90 degrees. If you drop an horizontal here, perpendicular to it. This will be 30, 60, this will be 30. So this will be 30, 60, this will be 30. Okay, finally at point B, it will leave with an angle of how much? 30 degrees it will leave. It will leave the magnetic field region at an angle of 30 degrees. So can we write, can we define the velocity vector? It's asking us to get that velocity vector. Velocity of particle when it comes out from the magnetic field is in terms of I cap, J cap is asking moreover. So it is in fact this angle will be how much? So altogether, how much of angle the velocity vector is making? 60 degrees with horizontal. Hope everyone is able to understand the way I'm showing the mathematics is possible here. So therefore, then what is the velocity of the particle at B? At point B, the particle leaves the magnetic field. At point B, the particle leaves the magnetic field. So therefore, what we can write it as velocity of the particle will become V cos 60 degree I cap, V sin 60 degree J cap. So this will become V by 2 I cap plus V root 3 by 2 J cap. Okay, all of you? This is the first part. Now, time spent by it. What is the radius of this particle? Radius of this curved path. What is R should be equal to? R should be equal to mv by qb. That's all. So can we calculate the time spent? So how much of deviation it will have? This 30 degrees, no? So it's going to spend time. The particle will move like this here. This is the path. So shall we go for omega by theta by t? And what is omega? bq by m. What is theta here? Theta is 30 plus 30, the deviation. Or pi by 3. Okay, this we will write it here. So this is a time spent. Time spent by particle in magnetic field. I think it's all about the geometry, nothing to do. Now, after this, what about the distance traveled in magnetic field? Arc length. This is option A. Option B. Now, option C I'm discussing. Hope everyone looking at the, because I have a lot of space for diagram only, I'm writing here and there. The distance traveled by the particle in the field. So there's an arc length should be equal to, so that should be equal to only arc length. How to get the arc length? R into pi by 3. What is R? mv by qb. Pi mv by 3 bq. Pi mv by 3 bq. Okay, now whatever the step, you must bring the mathematics into it. Sir, how to predict that particle? It should be part of a circle. There's a main part, main discussion here. I'll go to the next one.